Hello, in this tutorial I will show you how you can perform mathematical calculation or analysis using Python script. To complete this tutorial, you must have basic knowledge of Python programming. So, first of all, you have to install the Python packages for doing mathematical calculation, which is called pythonxy. There are many packages available in Python to perform this type of operation. So first of all, you have to check Python is installed on your system or not. If not installed, you can install it from step 1. So step 1 is to install Python 3 and Python 3p packages, which I have already installed. So you have to do it first. And step 2 is to install the necessary packages that is covered in this tutorial for doing mathematical calculation. I am installing here 5 main Python packages for mathematical operation. And in the third step, you have to install IPython3 for using Python shell. And the fourth step is to install PyQt5 related packages that is required for graphical user interface development. And fifth step is to install Spider3, which is a very useful Python editor where you can write the Python script and see the output in the editor. These 5 steps are to installing necessary package for mathematical operation in Python. So I have already done these 5 steps. So to use the pythonxy, you have to complete these 5 steps. And I will show the uses of pythonxy from this section. So after running the above steps, if all the steps are completed properly, then you will get the Spider 3 editor. So search, I will search the editor from here, Spider. You will get the Spider 3 editor. Just click on it. Okay, the editor is open. In the first example, it is showing how you can check the data types of Python variables. So I will copy the code in the editor. Okay. In the first variable var1, 50 is an integer. So to check the type of this variable, just use type function. In the same way, var2 is a floating point number, var3 is a boolean data type, and var4 is a string data type. So to run this script, first of all I will save the script. It is default name is temp.py. For Python extension, you can also save the script on your desired location. I am storing here var.py. Okay, save the script. And to run the script, you have to press this play button and run. Here you can see the output here, float, bool, and for check the output more properly, you can click the variable explorer tab, and it is showing var1 is integer, var2 is float, var3 is boolean, and var4 is str or string. In the next example, it's showing the use of numpy package, which is mainly used for declaring list variable or array variables or doing mathematical operation. So in the new file, I will copy this code in the Spider editor Okay, first of all, to use the numpy package, you have to import it. Import numpy as it is the alias name in py, which can be used in the script. Next, a numerical array is declared here of 5 elements, and print will print the all elements at a time. And next, in dim, define the dimension. It is a one-dimensional array, and it will print 1 for one dimension. And len function is used to calculate the total number of elements of the array. Shape define the array based on the dimension. And the next array, my array 2, is a two-dimensional array. So if you count the size, then it will print the 6 elements in totals. And in this statement, a range array is declared, which will start from 10, and by skipping 2 elements it will generate the other elements such as 10, 12, 14, 16, 18. And in the last statement, the array tree is printed. So now I will save the file first. Okay, now I will run the script. Now you can see this is the output. First one, array element dimension 1 and 5 elements, and it is the shape, output of shape. Next, 6 element, and this is the range array output. Example 3, MATLAB to draw a curve. In this example, matplotlib library is used here. So it will draw a curve based on x-axis and y-axis value. I'll save the file with curve.py. Okay. To draw the curve here, MyLab module is used, and after using it, the alias name is set as PL, and which is used in the script. First of all, linear space is declared here. How this curve will be, so how the curve interval will be set, which is defined by linear space. In this statement, x coordinates is defined by using linear space function, and the value of y coordinate will be calculated based on x value. And for initialization, for drawing the curve, figure function is called here. Next, plot value is generated by using x coordinate, y coordinate, and third parameter indicate the color of the curve. B for blue, you can use R for red, G for green, etc. And in this statement, level of the x coordinate is set, and in this statement, level of y coordinate is set, and the title of the curve is set by the title function. And when the show function is called, then curve will be drawn. So now I will run the script. You can see the curve here based on the x and y value, and then it will draw a green curve. By changing this figure value, the shape of the curve can be changed. Now I will go for the next example, example 4. It shows the use of SymPy module for creating symbolic variable. So you will go in the spider register again and create a new file, and save the file as save. Okay. Here SymPy module is imported like this from SymPy import all, and here first symbolic variable var1 is declared here, which is defined as true. So if I check is it imaginary or not, it will return a value true or false. In the next statement, var2 is another symbolic variable which is set to positive, true. And if I check the var2 is greater than 0, which is true means 1, so it will return true. So if I run the script, the output is from the first print is imaginary not, so it is false, and it is greater than 0, that means true means 1, so it is true. In this way you can do many other operations using this package SymPy. Here just showing the how you can declare symbolic variable in Python script. And now I will go for the example 5, creating data frame using Panda modules. So I will copy the script and store it in other files, paste, and save the file name as pandas. Okay, pandas module is mainly used to work with data frames and arrays. So here first the module is imported as pd, and next an array is declared here, where this is the array name is marks that contain the student name as property name, and which contains 3 marks for each students. So when I use data frame with this marks variable, then it will generate a data frame which is printed later. So if I run the script, then output will be like this. This is the student name which is assigned as title of the table, and this is the subject 0, 1, 2 and the corresponding marks of the student. So this type of data frame can be generated by using pandas module. Now I will go for the last statistical example of this tutorial. Example 6 is based on SciPy module, and the output of this module cannot be generated from this editor because it does not support this module. To check which module is supported by this editor, you can go for the help and dependencies. Here you can see it supports pandas, numpy, which that have already shown, and another one is SymPy, which is shown. And now I will, so to check the use of this module, I will do it from the terminal. So I will open the terminal. First of all, go to the Python editor and import numpy, and then import SciPy, and then from SciPy special import cbrt. cbrt is used to calculate the cube root of any number. So here I will generate the cube root of 3 numbers by this statement. Cube root of 8, 27 and 64, which is 2, 3 and 4. Now I will print the result of result variable, Here you can see the cube root of 8 is 2, 27 is 3, and 64 is 4. There is another example of SciPy module which is used to calculate the linear algebra, and for this I have to import the module linearG for linear algebra, and import numpy with alias name np, and declare an equation for calculating the linear algebra value. 3 array elements is defined for defining the equation, and next the value is defined by another array which is coefficient value, and now run the linear algebra solution by using solve function. Okay, now print the result. Print result. Okay. This is the output or solution of this linear equation. So in this way you can do different type of mathematical calculation and or analysis or data frame using various modules of Python. So here's some common use of pythonxy is shown here, but there are many other modules exist in Python for doing other mathematical operation or scientific programming. Hope this tutorial will help you to start pythonxy and solve your mathematical problem using Python script. Thank you for watching the video.